Hi there, and good afternoon, everybody. Thank you for coming out for our panel on Istio, how to make multi-cloud applications real. I hope that everybody's been having a great summit, and I know it's, we're getting later in the day and getting later in the summit, and so this should be an exciting session. We have a lot of great speakers here, and we'll get started right away. My name is Chris Hodge, and I'm the Senior Strategic Program Manager for the OpenStack Foundation. I'll be moderating this discussion today. This has actually been a fantastic opportunity because I knew very little about Istio before I came into this, and so it's been really great talking to everyone on the panel and prepping for this, and I'm hoping that you'll be as excited to learn about service mesh as I've been over the last few weeks. Directly right here is Stephen Dake, who is the principal engineer at the office of the CTO at Cisco. Next to him is Kostin Manolake, who is a Google engineer at Google. Next is Lin Sun, who is a senior technical staff manager and master inventor for IBM. And then last but not least is Zach Butcher, the founding engineer of Tetrate. So everyone, just a big round of applause and a welcome. Okay, so I think that it's important to start the discussion of what is Istio, and in particular, what is a service mesh. And so let's just kick it off right away, and let's maybe get a definition of what service mesh is, because it's something that I know that I think about, I look at Kubernetes, and there's supposed to be applications and load balancing and things happening there, and I wonder to myself, why do I need another layer when supposedly I have those things ready for me right away?
I guess I'll start. So the way I think of it is Istio is a layer 7 network monitoring system and network control system. It's sort of like an SDK. So when you develop software, you develop it towards an API. In the Istio model, you don't really do that. You just connect directly with your sidecar pods, which are sidecar containers, which are part of Kubernetes when you launch Istio. So these folks might give a better explanation.
Yeah, if we think of Kubernetes as abstracting away compute from our applications, I don't care what machines are running my jobs anymore. I just say, hey, Kubernetes, go run this. Istio's goal is to provide similar abstractions for networking, so that my application can say, I just want to talk to this thing, just make it happen. I know that there's a thing named foo, call it. And the goal is that in the same way that Kubernetes makes you not care about the physical infrastructure quite as much, Istio should make you not care about the actual network quite as much. Your application should get to kind of pretend that the network is the network that we all wish that we had, not the flaky network that fails.
Well, my turn to my view of Istio. So yes, Istio is a helper that allows you to take your applications and make them communicate with other applications running maybe in the same cloud, maybe in Kubernetes, maybe somewhere else. And we are not a middleware layer. We're just trying to integrate and to make the life of developers easier by taking care of some of the painful stuff that happens. Security, tiny details.
Yeah, I guess I want to add a little bit of history of Istio. It's a project funded by IBM, Google, and Lyft May last year. So we've been come through about a little bit over, I guess, right about a year at GlueCon initially when we first launched. And the way I try to think about Istio is from a user perspective. Istio really bring a lot of capability to you for free, as far as you don't actually have to change your application code to be able to leverage these features. Like Zach talked about traffic management, the network management capability. If you do that within Kubernetes, one example I would say, if you want to route like 99% of your traffic to version 1 of your service and 1% of your traffic to version 2 of your services, and to do that in Kubernetes, you really have to launch like 99 instances of that service for version 1 and Istio, one instance for version 2. So it's a hard problem within Kubernetes without Istio traffic management. The other thing is mutual TLS, like Costin was just mentioned, right? With Istio, you have the capability to enable your microservices that's deployed within Istio to have be able to communicate securely through mutual TLS. The other big thing is telemetry. Once you have your application deployed into Kubernetes, I mean, it's not like you just deploy out there. You're going to find out what exactly going on with your application, you know, where are you spend times onto each of your services. You're going to need to be able to gain observabilities into your microservices. So that's the other thing Istio is going to provide for you without any code changes. The only thing we ask you for small code changes is to change your propagate the headers so we know multiple trace spans are tied together to a single request. And then the other thing is also Google contribute the policy enforcement into Istio, so it allows you to control policies at a global level. So these are the 4 key pieces that Istio can bring to you on top of running your microservices within Kubernetes.
Yeah, so yeah, and that's I think this was kind of it's for me it's nice to hear these different points of view of how Istio works, because it's you know, I know that one of the things that was a big clarifying moment for me in trying to understand why I might want to use this is that, you know, Kubernetes serves applications and Istio and other service meshes serve network. And what's it like to integrate the two together? Is there what's the learning curve for this? How difficult it is for me to, you know, for someone to start like plugging in a service mesh, you know, because as a developer, you know, one thing I keep hearing from developers when I talk about this is, I thought it was easy to just like push my Git code up and it would containerize and be deployed, and now there's another middleware for me to have to work through, and so what's it like to integrate it with Kubernetes and other application services?
So I do, and Lynn touched on this a little bit, is that if Istio is actually doing its job well, it should be transparent to your application. Right, so you should be able to take a set of working applications and deploy it on top of Istio, and it should still work. Now, in practice today, there's still a lot of rough spots there, and you do kind of have to massage the Istio config to make things work. But the intent is that Istio is fairly transparent, and at least initially, it really shouldn't change the way that you develop applications. It's really only after kind of your organization has adopted Istio, you've really started using it, and you've started doing things like policy enforcement. As an example, one example of a policy that you can enforce is authentication and authorization. So there's the potential that you can offload auth-in and auth-z to the mesh, and your applications don't have to start dealing with it. That's one particular example where you can start to kind of offload this common functionality that all of your applications in your organization need to implement into the mesh, and it gives you kind of one place to go implement this, and you get the effect of that across all the applications.
And I think you asked about the installation process sort of in your question. Installing Istio takes about 3 to 4 minutes, very straightforward. Learning about Istio might take you longer, learning how to use it and whatnot effectively. So the ramp up time might be a little longer, but the initial installation and running the samples that come with the software, probably an hour of time at most.
Yeah, and I would add, it's one thing installing Istio, and after you install Istio, we take care automatically of adding a sidecar to your application. So when you deploy your application, automatically Istio sneaks in and captures the traffic, sees the traffic, controls the traffic, but you don't really need to know much about Istio to use it if the admin installed it properly.
And I guess one final question before we moved on to this is so Istio comes out of Google and IBM and Lyft. So I presume that Lyft is using this in production right now, and are there other organizations that are also using it in production?
Yeah, so Lyft contributed Envoy to the Istio project. So Lyft itself is not using Istio proper. They're still using a service mesh-like system built on top of Envoy and some of their own custom configs. maybe you can talk about the Google side of things.
You know, I cannot talk too much about the Google side, but we have been using a very similar system in production for quite a while, and we are quite happy with it. So I think that's public information. Yeah. And the main component, which is the sidecar lift, provided they are using it in production, you know, quite a lot. So it is pretty well, pretty stable.
Yeah, at first, and pretty substantial traffic too, I want to point out. So Lyft is doing, you know, millions of requests per second through Envoy. So that's a, you know, so they have managed to build a very stable, reliable production system on top of Envoy, and Istio comes in and gets to reap a lot of the benefit of that that expertise from them and that they've built into the proxy, right?
Yeah. Yeah, I guess the user scenario I would add is we actually run a user community meeting every other Thursday where we invite the community member to talk about how they use Istio. So one of the company, I believe it's Namely, so they actually did the community a really interesting demo on how they use Istio for telemetry. So we talk about the 4 key functions of Istio. You actually can adopt one function at a time at your will. So the company, Namely, when they started to look at Istio, they were like, well, I'm not going to look at mutual TLS. I'm not going to do traffic management. The only thing I want to start with Istio is, you know, I want to gain observability into microservices. I want to know exactly what's going on with my microservices. So that was an interesting user case where they can, you know, just bring their microservices, even though it may be 1 or 2 microservices, and then they can start to roll out with the telemetry feature of Istio. The other thing I want to mention is the weather company, which is an IBM-owned company now, but it's still kind of run on its own thing. So if you have the weather mobile app on your phone, that's the weather company is for. So they actually become a really huge fan of Istio, and they travel to Copenhagen at KubeCon to spoke about their usage of Istio. And interestingly, their first usage of Istio is also telemetry. They have 40 services deployed, and they really want to know what exactly is going on with their services. When there's a problem, how do we find out which one of the 40 services is causing the problem? So they find out telemetry is tremendously useful for them. And then they're also using for traffic management.
So just to expand a little bit, if you do a little speculation by reading the mailing list, it seems like a lot of people are doing evals, and some people are actually have it in deployment, even though it's not 1.0. So I see that all the time when I look at the mailing list. There's questions that are coming in. How do I get this installed? What do I do with it once I get it installed? And these people seem very interested. Seems like Istio does have a lot of fans early on.
Yeah. Okay, well, thank you. So we're going to move on to the next part of the panel discussion, and this kind of hits at the heart of the topic of the discussion. And what about multi-cloud? Like, this is, you know, we've talked about Istio, you know, kind of as, you know, sitting on top of Kubernetes, but you know, it feels like, you know, the tying together of all of these different applications and services. It seems like that for authorization, you might be running on some, you know, some system in some cloud, and for billing might be running somewhere else, and your application may be doing, you know, being in a totally different location. So, what about multi-cloud on Istio? You know, how does it work, and is it only Kubernetes?
Yeah, I'll get this started. So there's, I think, 4 different major components of multi-cloud. Maybe I'm off by number. I'll list them out, though. We've got something called mesh expansion, which we can talk about today. We've got multi-cluster, which is Kubernetes only. And then we've got some building blocks that have been put in recently called the V3 routing rules, and those permit the ability for true multi-cloud in the future with something called zero VPN. So those are kind of the things that make up multi-cloud. Things that are working today are the mesh expansion, the V3 rules, and multi-cluster. The other stuff is kind of future roadmap.
We also have some plugins for Consul, Eureka, Zookeeper, whatever. Yeah. So we integrate with as many systems as we can find, and we welcome any other contributions about other systems. Yeah. The system is designed in a modular way so that it can talk with anything, get information, and then make decisions and provides the features.
Yeah, because that is kind of a common misconception that I think we should clear up, is that Istio is not Kubernetes only. It works perfectly fine in other environments, and the intent really, probably the most common multi-cloud in the world today is on-prem to a single cloud vendor, a single public cloud. Very few, very few companies legitimately have multi-public cloud deployments and strategies, right? It's a relatively small number. So that non-Kubernetes piece of the market, very few people also have Kubernetes on-prem either, right? If we go look at on-prem deployments, the vast majority are going to be VM-based or just raw hardware even, just raw. So those are important targets for Istio as a project. And so it's one important thing to take away is that Istio is not Kubernetes only, but it is Kubernetes first and works best on Kubernetes.
So how does it manage that transition from this kind of cloud native Kubernetes centric thing to be able to run on like say a Google public cloud or an OpenStack public cloud? How does that transition work?
Sure. So fundamentally, really, Istio only needs one thing for its environment, and that is IP connectivity. So as long as all the workloads where Istio is running can talk to each other, Istio will work in whatever that environment is. Kubernetes makes that very easy because of its flat networking model and for a lot of other reasons. The fact that it already has service discovery built in, for example, so that running on Kubernetes, Istio can just kind of steal the service discovery information from Kubernetes and present it to everything running in the cluster, right? Obviously, when you're running a VM-based system or some other non-Kubernetes system, we have other methods of service discovery that get used, and to Costin's point, things like Console and Eureka, Istio can plug into and use to help serve the mesh, right? But otherwise, so yeah, and the two critical components, IP connectivity, and then you need to be able to put the sidecar proxy there. And we have scripts, for example, that help deploy the sidecar proxy to VM workloads and otherwise, you can hopefully plug in your Console Eureka or other, DNS-based service discovery things.
Yeah, I think these are really good. I guess we also have just added Cloud Foundry support too as part of the multi-cloud. That would be the addition I would want to add. So when I think about multi-cloud, I'm really thinking about high availability through multiple cloud, and also be able to take my application that may be running on one cloud and migrate peacefully to the other cloud. So if you look at your multiple microservices, you may have most of your microservices starts with one cloud, or maybe even your services are running on VM, but you want to gradually move your services to be maybe running on Kubernetes basis, and then gradually move one service at a time to the other cloud. So these are the interesting cases. So not just think about multi-cloud as running of multi-cloud, but also migrate. It's kind of your journey into the cloud native world.
Yeah, and just a quick thing about mesh expansion. So mesh expansion is what allows you to connect VMs to containers, for example, OpenStack to Kubernetes. And it's kind of difficult to get into the explanation of how it works here, but it does do that, and it works. It's been working since, I think, 0.2, and we're on 0.8.
But is this more dependent upon applications and services that allow for that, or are you actually developing drivers for particular clouds?
Yeah, it's some clouds need drivers to present their object changes to the system, but a VM system doesn't need that at all, because it's just one VM usually. But would say an OpenStack cloud benefit from a targeted driver, or is it just something that that users could take advantage of right now and not have to worry about special integrations for that? I don't think there's special integration required, although it might be helpful.
Yeah, an example of where a special integration might be helpful is in maybe some of the network setup for VM-based deployments to achieve that connectivity, which is not necessarily straightforward to do everywhere. But in general, Istio is built to be agnostic to that, right? Istio sits right at L4 and above, and it sits on top of the network that it's provided. So as long as there's a network there, Istio really doesn't care very much about where it's running or anything like that. So I think it would be kind of a failing on our part if it was required to have per cloud adapters. Now, if you want to do cool stuff with your cloud in particular, then yes, obviously you need some shim there, right? But as an OSS project and the core Istio feature set doesn't depend on any particular cloud provider or any shim or anything like that.
If I can give a slightly different answer, we can benefit from any custom integration, and we can learn a lot of stuff from the custom integration, but duct tape always work. So we are trying to have both worlds.
So one of the major themes that I've seen repeatedly over the last week and at the summit is security. A lot of it's been focused on container security and about the idea that containers don't contain, and how do you protect containers from attacks both internal and external, and the network even more so. Like the network is the most visible part of your infrastructure by design. And how does Istio handle security within a mesh network, especially in a multi-cloud environment?
Okay, cool. I'll tackle that first. So fundamentally, the way that Istio achieves communication security is by assigning identities to every workload. So every service gets an identity, and that identity is encoded inside of a certificate that's used to establish an MTLS connection. And so what that means is that both services have, when we establish a connection, we actually have authenticated principals that we can use to implement policy on top of. So we can use these identities that Istio is assigned to say, no, A can't talk to B. We don't want those things to happen, right? Because we have these strong principles that are associated with the connection. And so in that way, Istio provides both, it starts laying the groundwork, right? So secure communication, and we'll get into no VPN stuff later, but MTLS and secure communication is the basis for that, or a requirement for that. And then really that application identity, moving the trusted part of a request from things like IP from the network to L7 things that we can drive at a higher level.
Slightly
Sure, yeah, please.
Well, so I
can tell, sorry.
Well, I guess I just want to add what Istio really make it easy on the security front for you is you can always start without security, because I know I like to do that. When I try my microservices deploy within Kubernetes, when security turns on, that's one thing, it's just so hard for me to debugging and tracing through. So one thing Istio made it really nice, to Zach's point about secure communication, mutual TLS, is you can actually start without mutual TLS between your traffic, and then through security policy, you can, as you get ready, as you roll out your application to the service mesh, as you feel confident your application is working, you can enable that security through a simple policy toggle. So that's really make it handy. The other thing I want to say is Istio also made it easy for you to control. Like if you have 3 services, maybe one service can access the other service, but only on the read. The third service can access the service on read and write. So you can also control the access of your services through Istio very easily by applying a security policy around the destination of your service.
I just wanted a very short, kind of lower level. The first step to security is to not trust your network, yes. And to encrypt everything. And that's what Istio does at the base level. It allows the sidecar to automatically encrypt, take care of certificates, take care that nothing goes in clear text. And then there are additional features that were described.
So that covers the aspect of security that is involved about making sure that your traffic can't be read. Are there any features involved that protect me from things like DDoS attacks and rogue processes? Like, are there because I know that within Istio you can set up rules about that can monitor your network, and is this useful in preventing that sort of external attack too on whatever your application service is?
Things like rate limiting are another good example of policy that Mixer can apply. Now, for things like a DDoS attack specifically, there are probably other mitigations that you would like to take that lower level network mitigations first before you move up to L7 mitigations. So maybe DDoS isn't the perfect example, but things like unintentional DDoS internally inside of a cluster, right? I spin up my new version of a service and I accidentally have a loop in there and I call somebody else a whole lot. That has caused a lot of outages at Google, for example, has had many outages of that category. And so things like rate limiting that Istio provides are a good tool for, sorry.
Yeah, not user visible and
No, nothing user visible. I want to, yeah, sorry. And to give a little context,
Google, so.
to give a little context, I worked for Google on Istio as an early engineer up until 2 weeks ago. So and then left to go start Tetrate, which is an Istio focused company.
Congratulations.
So I have context there. Sorry, I'm not just totally talking.
Luckily, we have something similar with Istio to prevent the outages to reflect outside.
But that's a legitimate problem that more than just Google has had. Plenty of companies have accidentally DOSed themselves internally. That's a pretty common outage pattern. And so there are other tools that Istio provides to help, other policy, for example, that you can apply. But specifically back to security, things like DDoS is a specific example you probably want to handle elsewhere. But really, these primitives to secure communication are really where Istio is at. And by the same token, rogue processes are really kind of out of scope of Istio, right? Because we don't care what you're running. We care about the network aspects of things.
Did anyone else want to have any comments on that or?
One word, circuit breaker. We have a circuit breaker that can also help.
Yes, that's it, yeah.
But it's not really for DDoS.
Yeah. What is it for?
Circuit. Go ahead.
What is it's called? So to repeat, it's
you can control how many requests the service accepts. If you have more than 1,000 QPS, it will break and start rejecting. So you can prevent too much load on a single.
Okay, and so it'll shut down the load from or to a service.
To a service.
To a service. Okay.
Yeah, it's pairwise. So circuit breaking, right? So the intent of circuit breaking is similar to lame ducking, but and the intent is to kind of help stop cascading failures. Okay. And so the idea is that if I'm calling a backend and it's failing a whole lot, I want to stop calling it for a little while. It's similar to lame ducking, except that it provides kind of global QPS caps that you can do per client and that kind of thing as well. So it's a little bit more sophisticated than lame ducking a service that you're calling, which is just taking it out of a load balancing rotation and then trying it again later.
Okay. All right. Okay. So with that, we're going to move on to the final part of our panel discussion, which is it's all about the future, which includes the work that they're doing here, but also possibly work that the audience may be doing. So are there any features that are really exciting that you're working towards in your 1.0 release and things that that you'd like to talk about?
There's lots of things. It would take more than 14 minutes. I think if we limited it to just multi-cloud, there's a few things.
Okay.
So we could do that. So for multi-cloud, we've got mesh expansion. That's one feature that's needs some love and caring around deployment. So like an Ansible playbook or something would be helpful there. And then we've got multi-cluster, which is a way of connecting networks, Kubernetes-only networks on RFC 1918 networks. So you can connect multiple clusters together. That's what's coming in 1.0, and that's already in 0.8 as well. For the future stuff, this is why we brought Zach. So.
Do you want to talk first before? I've been talking a whole lot. I feel. Yeah. So a lot of the future stuff are new networking APIs that we've put together, and the first release that'll really have these is Istio's upcoming 0.8 release when we eventually get it out.
It's been 2 weeks now for about 6 weeks.
Yes, it's been a while. But 0.8 will come out and introduces some new networking APIs that really are the primitives that you can use to build Istio deployments that let your applications talk across clouds without knowing about it. right? Because that really is the intent that we want to get to, is that your applications don't care where other applications are running. They just know that they can talk to them, and Istio makes it happen. And so the new networking APIs that we've introduced put in place a lot of the abstractions that you can use to build deployments that do this. And I think over the next couple of weeks and months, we'll start to see kind of tooling built out on top that helps make this a lot easier to achieve.
Yeah, and just to expand on that, what Zach is talking about there is this work called the ingress gateway and the egress gateway. And the way I think of it is, instead of having nodes in a cluster, you have nodes in a multi-cluster. So each cluster can communicate with each other through the ingress and egress gateways. This requires more advanced management, and that's what Zero VPN is, I believe.
Yeah, that's at least part of it, right? But so the general principle of Zero VPN, to explain that term, is that you can use Istio to build applications that span multiple clouds without needing to use VPNs to secure the communication across those clouds. Because Istio provides the primitives that you can use to start building a zero trust network, you can use those things, and in particular the fact that all communication is secured via TLS and is authenticated and authorized by an identity. You can use those features to shift where you trust from the network, where traditionally we'd use a VPN to bridge networks together, and because I know that this is part of my trusted network, it's fine. And we can start to shift that trust to higher level concepts, which means that you don't need VPNs to bridge large networks together, which opens up a lot of really interesting opportunities, like routing, cloud to cloud across the internet, for example.
Yeah, I guess I want to mention this egress gateway. I thought it was really interesting when I first started looking at it. Like, if you think about today's application world, you can't just write applications using your own code. Your application is going to likely to consume some services in the cloud, and it could be some artificial machine learning services. So in that case, with egress gateway, you can actually control, for each of your microservices, you can actually control what type of external services you can access. So from a Istio perspective, the operator, I guess the admin of the mesh has full control of the developer on, what exactly the services they can access, which is a really powerful thing. Well, as far as the future, I want to mention a couple of things we're working on. I think a key thing is we're trying to stabilize Istio and make sure we can actually have a production-ready release to our users sometime in the summer. And also, we are trying to make sure it's clear to user that Istio is not like a big meal. We're trying to ask user to consume Istio for the portions they need. Like the example we were talking about, telemetry. You could just consume Istio for telemetry, and that's a perfect valid scenario. So I know we talk about Istio is easy to install, but the documentation is actually really long to digest. But so as you start looking at Istio, our website is istio.io. I would recommend you to follow the pattern of the ones you are interested most and dive into that. So we're trying to enhance user experience, adoption model for like key practices for a user, so they know exactly what to start as they look into Istio. The other thing I want to mention is the community is also looking at the UI support for Istio. I think that's tremendously interesting, looking at how do I apply Istio security policy, how do I apply Istio network policy through a UI. So that's, and also be able to visualize to see the traffic shifting in live. So that's really, really interesting too.
And just I want to your earlier point, Lynn, one of the big kind of misconceptions with Istio today is that you have to adopt all or nothing. And we've talked through, we've listed all these features, and there's like a lot of features and it's a lot of things. And if you go actually deploy it into a cluster, you see that it's like not a small number of services that get deployed too. And so it can be a little off-putting at first to look at. And so one important takeaway is that Istio can be run piecemeal. And if you find one particular feature that is compelling for your use case, you can deploy Istio to get that feature and none of the other ones. And and to Lynn's point, that's something that we haven't done a great job of documenting yet. but it is possible, and there are some examples out in the wild. And so don't be put off by it being so much stuff at first, because you can really pick the pieces that you want to use.
Short, stability, polish, documentation, stability again, scale, and in general, Istio everywhere is kind of the future that I'm trying to get. And of course, we'll have a lot of features added, and because everyone has some idea of a feature and probably we can implement it. But at the same time, we're trying to keep also the stability in check.
So Chris, I hate to interrupt, but I think there's a question. Somebody raised their hand.
Yeah, so we have just about 5 minutes left, and so if you have any questions, please step up to one of the mics, and we'd be happy to take your questions for the remaining time.
Thank you. Good presentation, good panel discussion. Can you tell us about service meshing if you are going to deal with edge? Any takes on that for future?
Sounds like a custom question. Edge is in IoT?
Edge as in 5G as in IoT, all three.
Yeah.
All two.
Oh, IoT.
Yeah, that's a special interest of cost.
Yes, that's my favorite topic. Yeah, Raspberry Pi, ARM. Yes, absolutely. It's my hobby.
It's your passion. So what do you do about it? Are you delivering to every edge?
I have Raspberry Pi running Envoy, running Pilot, running pretty much everything. It's not officially supported, of course.
So that's what I want to see.
But Envoy, it's a very light process. I mean, it takes almost no memory, no CPU. It works, too well on Raspberry Pi is too much for Envoy, and most of the components are very light, and it's probably past time to have good security on IoT devices as well. So.
Okay, thank you.
But in the short end, to extend your answer, that's also another area where more community involvement would be very helpful, right? If that's an important use case that you want to see Istio extend to, then start to get involved and help drive that. Because right now there's not somebody really driving IoT as a focus or edge as a focus in the Istio community.
Yeah, it's a 20% project for me, so.
Yeah, Kasten, yeah, it's very interesting, but yeah, you have a real job to do too.
Yeah, Adam over here.
Hi. I'm on here. Adam Young, Keystone Core, and been very interested in Istio because I'd like to use it to replace Keystone. The last year at the summit in Boston, I presented on trying to move our RBAC, specifically the role check, to middleware. And it seems like Istio is trying to do the same kind of thing. And one of the there's several issues with that. I would love to talk through technically, but the big one is I was called on, I believe they used the term the Cambriac explosion of APIs, that everything that you need to enforce policy on has to be pre-enumerated inside your enforcement layer. And it seems like Istio would have exactly that problem. How do you keep from Istio having to have a complete encyclopedia of all API calls and then complex policy on top of it?
Who wants to take a stab at that?
That was a good question.
I want Steve to answer that one.
Yeah.
I don't think I can, actually.
Well, tooling,
Yeah.
that's one answer. In the end, to apply policy, you need to know, what you're applying on, and there is not so much magic we can do.
Yeah.
But tooling, learning, all kind of stuff can help a bit.
I think also if you look at the B3 APIs, they're pretty simple and straightforward. It's probably not to the requirements that you ran into with Keystone, but it's pretty close. I think it delivers most of the things you would need for a secure network, but it is an alpha API, so it's not finished yet. But I think today it does have many of the functions you would look for without a bunch of API rewrites. So.
Can you track across, so I can understand you could link service A to service B, right? But if you have a workflow, and to use an OpenStack example, like when you create a virtual machine, Nova ends up calling Gland. So you have the user calling Nova and then chains on there. Do you have the idea of like a request ID and being able to enforce policy? Because your TLS is no longer good, right? If the first user did it, maybe authenticated to the second. How does that work on a multi-hop scenario?
Yeah. Do you want
There is in progress. It's not yet fully implemented, but you will have access to the identity of each hop if you are doing hop by hop TLS, or if it's end-to-end securities, then you'll have end-to-end.
But yeah, and user credentials are yet again a different issue, right? Because you need to handle propagating that in your application. And Istio will be doing stuff to help that in the future. There's a white paper called the Macaroon white paper that Google published that talks about the concept of tying end user credentials and application credentials together as they forward through your call graph.
So it is part of what you're addressing and planning on addressing in Istio?
Yeah, not yet, but eventually.
Well, okay, so in the interest of time, maybe I think this is a good starter discussion, maybe for one of the mailing lists. I wanted to get one more question in before we ran out of time.
Yeah, Parviz Yagani. Istio, you mentioned a lot about the control plane, the intelligence there, but very little coverage of the envoy on the data plane, the sidecar. Specifically, when you mentioned the policies and the telemetry. So is there any strong linkage between envoy and Istio, or they can be separated at the code level?
So it still has control plane and data plane. So the control plane are the pilot, mixer, and the security piece. We recently had a new name, Citadel. The data plane, what Costin briefly touched on, is as you deploy your microservices into the mesh, every single of your services is going to have a sidecar that's going to be coexist on the same pod as your services. So that sidecar is going to trap all the incoming traffic and also all the outbound traffic for you. So that's how Envoy as a sidecar plays a critical role in the data plane to be able to send the metric for telemetry, to be able to do policy checking, to be able to do traffic management for you, and also be able to hide secure communication for you.
Yeah, but
so I hate to cut this short, but we're out of time for the session. But we would love to continue the discussion.
Come on down and
privately after this, so we can get ready for the next session. And thank you to everybody for coming and for the panelists for the great presentation.